Hi everybody, my name is Victor Gunn. I'm a Combine Product Specialist for Western Canada. Today we're going to talk to you about some 250 series features and benefits, some of the new stuff coming for 2021. With that, we'll get started. I got a little bit of a slideshow here for you. Harvest more of what you grow. Basically, that's one of our mottos. We want to put more grain in the tank, more money in the bank for you as a customer. Quick slide showing the sensors with our automation system. So basically we've got 16 sensors throughout the combine. A lot of those sensors did come on previous model combines. Some of the new stuff, we've got things like the Sieve pressure sensors that you see over here on the left hand side of the slide. Right? Grain cam, that's new for the automation system. Like I said, there's a few new ones, but the majority of them came on previous model combines. Feeder drives and lift improvements. So we now have 3 cylinder offerings. We have a light duty, a medium duty, and a heavy duty offering in our packages. The light duty with a 10,000 pound lift, good for those 30 or 35 foot heads at max, so the draper heads. The medium duty, 11,500, that'll get you up into the 40 and maybe the 45 foot draper. In excess of a 45 foot draper, you're going to want to go 13,500 pound lift and the heavy duty package. Also, 16 or 18 row folding corn heads, you're going to want that heavy duty lift package. Quick picture of the mounting hardware. So you can see in the bottom picture, we changed the lift bracket mounting locations for the cylinders, right? The cylinder style also changed. You'll notice that they're a double acting cylinder, so you're going to see 2 lines going to the cylinder. Keep in mind, the second line is still dead. It's just a return to sump. We don't physically put hydraulic down pressure on the feeder house. It's still acting as a single acting cylinder. Feeder drive. So we have 2 gearbox offerings down at the bottom of that feeder house now. Again, if you're into those 16 and 18 row folding, chopping corn heads, you're going to want that heavy duty gearbox. All right, good idea to have that heavy duty one. You'll know it's the heavy duty style as the gearbox is physically black. Dual lateral tilt cylinders. So at the front of the faceplate, we can get dual factory fit lateral tilt cylinders. So if you're into those big draper heads, 40 foot drapers, 45 foot draper heads, to help take some of that sponginess out of the lateral tilt, it's a good idea to have the dual lateral tilt cylinders in there. You'll get a lot crisper action with that lateral tilt. Front pivot changes, right? So with the big heavy heads, and as we're proceeding, we'll see bigger draper heads coming down the pipe. That pivot needs to be beefed up. So from the 3-bolt style, over here on the one side, we've gone to a heavier pivot, and you know you've got at least 11,500 pound lift based on just looking at the pivot style. So 11,500 pound lift, 13,500 pound lift has the heavy duty style pivot. With that, we've also bumped up the hardware size on the feeder floor, right? So we put bigger bolts in there. We went from a 3-piece floor to a 2-piece floor. And anytime you get rid of a seam where material passes by, you reduce a wear point. So we want a heavier duty floor. It's a little bit more wear resistant and heavier hardware. Floor geometry changes. So we've made a few changes in the feeder floor as well. That floor is now 20 millimeters lower in the feeder house than it was in previous model combines. Quick graphic showing what the feeder floors have looked like throughout the years. Back in 2009, we started with a lower position. So the blue graphic, you can see, we actually experimented with dropping that floor wide open, all right? We found that we didn't get as good a feeding as we'd like to see, so we actually had a program where we went around and we lifted the feeder floors up significantly. So up until 2018 or 2019, so the 2018 and previous floors were in that position. We are now in between the two. So like I said, the 250 series floor is 20 millimeters lower than it was on previous model combines. Give us a little more capacity in that feeder house, a little room for those bigger materials. Big change in the top left corner. So the gearbox that drives the Rocktrap beater as well as the feeder chain, big changes in that area there. So on the previous model combines, and we'll show you in a little bit later video what the splines look like, we went from this style of gearbox to a bolted in spline coupler. So there's now a spline coupler that bolts into that top sprocket, and there's also a different spline that's on the gearbox side, also bolted on. So those two pieces are changeable, independent of the gearbox shaft and the top sprocket. And if they do happen to wear, you don't have to change the top sprocket anymore. You can change those pieces independently. The other thing we did, so in the old sprocket, there was a pin style slip clutch in there. So we got rid of that slip clutch. It's now located inside the gearbox. It's a fiber disc clutch inside the gearbox. We should get more longevity, more life out of that fiber disc clutch than the pin style clutch. We all know what that's like. They slip a few times and then they start to slip easier and easier. Feeder faceplate fore and aft. We'll talk about this one on the combine as well. Basically, you get in-cab adjustment, and the point of that is to match the head type on the combine to the front drum. So if you have a pickup head, for example, you're going to want to tip the top of that faceplate all the way forward. A draper head, we set it in the middle, and a corn head, we tip it all the way back. So if you're swapping back and forth between a draper and a pickup, it's a really nice feature because it gives you quick adjustment of that faceplate so that you get optimal feeding in your combine. If you don't take the hydraulic adjust, you still get some big bolts and manual adjustment, so it's still there. The other thing that comes with the new faceplate is you actually get about 1.5 degrees more adjustment than we had in the past. Feeder chains, right? So we upgraded the feeder chains. We've got a heavier feeder chain. So the inner side links are heavier, the pins are heavier in the chain, so basically a more durable chain all around. The pitch is still the same as it was in the past. We've just upgraded some of the components in the chain. So like I said, inner side links are heavier, pins are heavier, and you're getting a more durable chain. Transmission, probably my favorite option that we added to this combine. So we went from a 4-speed transmission to a 2-speed transmission. So you'll notice your shift knob is now a 2-speed, still stop to shift between first and second, but you have a shift on the fly, high and low in each gear. What does that mean for you as an operator? So in first gear and high range, for example, we can get 11.2 miles an hour. So if you're shuttling across the field to fill the truck, you're switching fields, you wind up in the far corner when you finish a field, you can get across that field a lot quicker without actually having to stop and shift. The other thing you get with this transmission and hydro combo is a lot torqueier hydro. So for example, we'll pull out onto the road in second gear and low. You pull out, you'll get up to speed, you'll hit your high button, and off to 25 miles an hour you go. You won't be pulling out in third gear, stopping in the middle of the road, you're holding up traffic, shifting to fourth, and then continue on from there. It's all shift on the fly in the highs and between high and low. Diff lock. So we changed the diff lock. We now have electric actuated diff lock. So instead of the big lever on the left, where you used to have to just about stand on in some cases, we now have a little electric button on the floor. So a lot easier operation to engage that diff lock. Lighting package, so we went from HID lights to LED lights. A bit of a graphic showing the difference between an HID and the LED package. Long story short, significant difference in the lighting package. Those LED lights really light up the world in front of the combine. Adjustable cage vanes. So long time coming. With 2019 combines, we've got adjustable cage vanes inside the combine. What does that mean for you? Well, basically you get a lot more performance out of your threshing system. So we have the ability to run it via automation. So our automation system is adjusting those vanes, or you can adjust them manually on your own. If we can keep that material in a little bit longer, they make a big difference in things like white caps. Maybe in that dry canola where we got to get that product out a little quicker, we speed those veins up and we move that product through a lot quicker. So huge benefits there. We've seen some amazing things just from adjusting those cage veins. So you can see that's a picture of the inside of the veins. The front two veins are still manually adjustable, but we made your life easier. We put panels up in the grain tank to allow you to adjust those veins if you need to. The rear 6 are all adjusted in cab with an electric actuator. So picture of the inside of the veins. So basically they're a 2-piece vane. You can see they pivot based on the center position, and then they just kind of pivot back and forth on that center position. The actuator, so that's sitting on top of the rotor cage. Again, electric actuator, and you'll see there's a bit of a graphic there showing the position of the vane. So very slow, slow, medium, and fast. All right, so some of the new things coming on 2021, we made a few little changes. Basically, a lot of them are in the software, right? So we allowed you to add the work condition in automation. So basically you get auto default, high moisture corn. If you want to set it as a high moisture, easy threshing, however you want to call it, you can set a work condition in there. We added a run screen shortcut. So if you're in there setting up your automation, we can hit that run screen button and it automatically takes you right back to the automation. Saves you 1 or 2 button pushes. Sieve loading. So with our automation system, we have sieve pressure sensors. This is something different than anybody else is doing, right? Nobody else has got sieve load indicators. So we've added bar graphs on the main run screen where you can physically watch your sieve loading. So if we're down in the yellow on the bottom side, that means our sieves are underloaded. If we're green and located somewhere in the middle, we're optimally loaded. Overloaded when we start to get to top. So a good indicator of what's happening on that cleaning chute. In the past combines, the automation system was watching the sieve pressure sensors. Now we can physically view what's happening to them as an operator. Factory fit camera options. So something we haven't offered in the past. So gives you the ability to order your combine with factory fit cameras, right? So 3 different options. Top code is no cameras. Option 2, you get a rear view camera only. Option 3, we get rear view and unload tube camera. So some nice options there. Get that combine set up as much as possible right from the factory. All right, let's talk about information. So YouTube is becoming more and more popular, and there's going to be a lot of videos coming down the pipe, training videos, marketing videos, online brochures, that sort of thing. So CaseIH has their own YouTube channel, so don't be scared to subscribe. So just a quick instruction on how it works. So when you go to YouTube and in the search bar, you type in CaseIH North America, it will take you to this page right here. So this is the CaseIH North America YouTube page. Within our YouTube page, we have our own search function down here. So down there, it pops over, and if we type in 250 series, all the videos that are available for a 250 series combine will populate in there. So like I said, there's training videos in there. If you want a video on the different buttons and what they do, that'll be located in here. If you want a quick video on how to set up your automation and your feed rate control, that video will be located in there. So good idea to subscribe to that channel. You'll get notifications when a new video happens to pop up in the new list. With that, that's the end of my presentation. Thank you all for tuning in.
Welcome to our 2020 Combine Clinics. My name is Louis Melanson, product specialist out of Western Canada. And in the next 40 minutes or so, we're going to run through this PowerPoint presentation over here. Basically, what we are trying to get accomplished here is to try to get your combine optimized to where you get the peak performance out of your machine. We buy these combines. We all know they're pretty expensive, and you need to be able to get these things to perform properly in the field. So through this whole presentation, this is basically a generic presentation. We'll be talking about stuff that applies to a 250 series combines, to a 240 series, a 230 series combines, an 8010, 20 series, and some of the stuff also applies to the mid-range combines. Okay, so threshing system are pretty much equal in all the combines that CaseIH built way back to 1977. So pay attention, because some of these things, a lot of these things are going to apply to pretty much all of the CaseIH combines. All right, so let's jump into this. And again, some of the adjustments that we're going to be talking about over here, we're talking about optimizing the combine. So they're not all necessary that you have to go in there and do all these adjustments. The adjustments we're going to be talking about is the ones that all of a sudden I go to the field, the crop may not be fit to harvest yet, but I need to get the crops off. So doing these adjustments will get a little bit better performance out of your combine in hard thrash conditions. All right, next thing. There is a site that you can go to get some videos on the 240 series combines. I know this is a long link, but if you take a picture of this and go in there and enter it, it'll take you to a YouTube site, and on there you will have different portions of the combines, so you can pick the ones that interest you the most. For example, I just threw one on here, pivoting spout operation on flagship combines. This will take you into how to adjust the pivoting spout to get the maximum performance out of it. And what do I mean by that? Okay, so if you have a electrically adjusted pivoting spout at the end of the unloading auger, that spout can actually be adjusted to a different position. So if it's windy today, I may want to set it to where when I engage the unloading auger, the pivoting spout is going to come and I can set it to where it's straight down. For example, I'm doing canola. We all know canola is a light crop. I need the wind to not blow my kernels off of the truck. So I would set it straight down. I go to wheat, then I'm going to put it at 70%, for example, and then it'll shoot a little further out, so I don't need to bring my combine as close to the grain cart or the semi or whatever I'm unloading into. Okay, and that's all adjustable. You tell it where you want it to go. And then you have the capability of adjusting on the go while you're unloading if you want to. This video will take you all through all those steps that you need to get done. And there'll be a whole bunch of other series of videos on the consoles, what the switches do. So you can take an inexperienced operator, sit him in front there, he can go through every switches, and he'll come out of there being an expert combine operator. Some of the things that we offer for 2020. We come out with a new track suspension. Okay, we all know tracks on tractors or combines, they give you better flotations in the field. Okay, so that's why we put tracks on it. If you work in muddy conditions, you put tracks on, you can get into the field sooner and be able to harvest your crop without having to worry about getting stuck. So some of the features on the new tracks. As you can see on here, PowerFlex tracks system. That's our trade name for them. Okay, so it has its suspensions on it to where if I go over rough terrain, the track will actually automatically smooth out the bumps and humps and rocks and whatever else that's in the field. Okay, so your ride is going to be a lot nicer using this type of track system. We still offer our standard track system that you've been ordering before, but now with this option, you get suspensions on it, which is kind of nice. The track itself is a new design track. It's a heavier track, so therefore it allows you to go up to 25 miles an hour with there's two different options. One will get you to 20 miles per hour. It'll have more torque. The second option will get you up to 25 miles per hour with a little less torque, but it's still quite usable in the field. So for a guy who does a lot of traveling, he may want to pick the option where I can drive 25 miles an hour and I can pull the header behind the combine without any issues. Shipping, this will be ordered through parts. Okay, shipping will start after July 20th. So we got them available for our combines, and you can also put them on some competitive combines. So there's more to come to that for that feature. Some of the kits that I talk about, and I should rephrase that, I shouldn't call it a kit. There's some components that you can actually put on the older series combines, like a 8010 for example, or a 20 series or a 30 series. These are things that we added to get better performance out of the spreading system at the back end of the combine. And so as you can see on here, this piece of rubber back here, I don't have the part number on my screen over here, but there is, if you go through to the parts counter and you ask for a curtain that fits between the sieve loss sensor pad and the tailboard, the chaff pan, then they'll go through the parts catalog and they can figure out what the part number is. What this rubber flap does over here is basically assures that the chaff and maybe some kernels, because we all know that combines, to get zero loss behind a combine, sometimes it's not very effective. Okay, so you'll be driving way too slow. Combines are made to save grain, yes, but there's a certain percentage of grain that is totally acceptable behind the combine. But you got to make a good job of spreading it evenly across the 30-foot, 35-foot, 40-foot, 45-foot header, whatever you've got on the combine. So what these will do is they will assure that whatever comes off the sieve gets onto this chaff pan, which then gets delivered to your spreaders. And then the spreaders can spread it to whatever width header that you have on the front end of your combine. There's also another rubber flaps on here, which is the same rubber flap you see over here, so the one that's right here on both sides of the combine. And those help to redirect material that's coming from the chopper itself. It'll come out towards the back end of the combine, it'll hit the sidewall, and then it'll divert it towards the center of the combine so that the spreaders can grab that material and spread it. Okay? And the same thing with these dividers around this pan over here. If your combine does not have those dividers on there, you can buy them from parts, stick them on there, and then the residue system will work much more efficiently. So that's what these curtains do. So these curtains will fit on an 8010, they'll fit on a 20 series combine, they fit on a 30 series combines. The 240 series combines, they were already installed on there from the factory. Okay, so if you look at your 240 series, the 8240, 9240, you'll see that these are already installed on there. Okay, so those you don't have to worry about. Another one, this one I got smart and I put the part number in there. Okay, so for lack of a better word, I call it a chopper knife retarder bar. And what this little option will do for you is if you happen to put some non-compressible object through your combine and they happen to go through a chopper, you have stationary knives located underneath the chopper grate, and as those knives get dislodged from rocks or whatever else, then it takes a knife and it shoots it straight down, and if you have the same luck as I have, it goes right through your sieve, and now you got to buy a new sieve. So what this bar does is actually bolts underneath the chopper grate, and then when the knife lets go, he comes down, he hits this rubber pad, and then it deflects the knife so it doesn't go through your sieve and cut your sieves apart. Okay, so that's what it's used for. Now, if you do put this kit on, just remember that if I go and I put the stationary knives all the way down to drop straw, and I go to raise them back up, the stationary knives might get caught underneath the rubber part over here. That's why there's quick snaps on here, just over center latch. You just pick them up, take the rubber piece off, move your knives up, stick it back on. Okay? But the beauty of this kit it will save you some money, because the sieves, as you know, is not, when you go, you can spend $1,000 real fast on a sieve. So. Another kit that we came out, we had a lot of discussion, complaints sometimes about customers saying a knife came off the chopper and it went right through the straw hood, and it hit the oil pan, and I'm worried that maybe one day a knife will go through the oil pan. Okay, so it was designed like that to begin with, but then later on we decided that, okay, we didn't have to design it like that, so we added 3 pieces on here. This is the roof off the straw hood. So there's 3 plates goes on there, and they're 1/4 inch thick, so knives will not go through the straw hood anymore. They'll get deflected straight down. So again, there's the kit number for it. Back in 2016, okay, we had some issues of wear on the feeder gearbox, on the shaft of the feeder gearbox, and also the top shaft. This is the top shaft here, where the feeder chain actually runs over top of these sprockets over here. So we were getting wear in the splines and also wear on the gearbox. So we decided to drill a passage right through, and the grease now can go straight down and go inside this cavity and actually lubricate the spline on the feeder gearbox shaft, and also on to the top shaft splines. Okay, so that'll help reduce some of the wear that could be happening in there. Another thing we discovered is if you're going to go in there and do any work, make sure that you laser level the gearbox in there with the top feeder shaft and also the beater shaft, and then that way that also reduces wear. Now the new shaft, in order to identify which shaft you have in your combine, if you take the top cover off over here, this is the top of the feeder house, you take the cover off and you can see inside, you're going to see the top shaft. Here's where the grease nipple is located. Should be 2, one on each side, one on top and one on the bottom side. There'll be a serial number stamped right into the shaft, right about here, somewhere in there. If you have a serial number stamped there, that means you already have the new shaft. If there's no serial number, it's the old style shaft. Okay? And while we're on this slide, we're also going to talk about, because you're looking inside here, you already got the cover off, inspect your strippers over here. There's one of these for each one of the sprocket that's up top. Okay, so what you're looking for is you want to adjust this as tight to the sprocket as you can. We want 1 millimeter gap back in this area. All right, now let's talk a little bit more. I'm going to switch gears a little bit. Let's talk about optimizing the combine. So again, these adjustments that we're talking about here is when you get into critical operating condition or field conditions, sometimes we need to kind of set up the combine differently than when life is really good and everything is dry and you're ready to go combining. So I always say, what is the first rule of harvesting? And I can guarantee you that probably nobody in this group knows what that is. The crop has to be fit to harvest. How many times do you guys go to the field that the crop is fit to harvest? You simply watch the next door neighbor, and when the next door neighbor hits the field, that means your field is ready to go. Okay? And not necessarily true. So we push the envelope all the time to try to get out there as quick as we can to shorten our harvest time. And a lot of times the crops is not quite ready yet. So some of the items to look for, first of all, when you get to the field, is go in there and look to see what your pre-harvest loss are. And then go harvesting and see how much header loss you've got. There might be leakage on the combine. And then after that, then it's basically understanding the combine. I could have some separator loss, I could have some cleaning loss. And that basically is accomplished by getting out of the seat. For these two right here, you need to get out of the seat and go look behind the combine. Now we have a handy dandy tool, which I have here on the bench. Okay, so basically it's a square, tells you how many kernels per square foot is allowed depending on the size of the header. So basically all you do is you just, as the combine is driving by, you've got two choices. Somebody else, you got another operator. The second person can just throw this behind the combine anywhere on the ground and go in there and count how many kernels is inside this square foot. Or if you're by yourself, just take your square foot, you throw it on the ground, and then you get on your hands and knees and you count how many kernels is actually in here. Okay, and that'll give you how many bushels per acre I'm actually losing. So, and there's actually a grain loss calculator as well that you can use, which is quite handy. You can put it on your phone, and then you can put the number, the size of the head, the size of the field, and then input how many kernels you got on the ground, and it'll tell you how many bushels per acre you're actually losing. But just remember that a lot of this kernels that you find behind here, the number that I have in my screen down here, that means that's square foot for every square foot that's actually in that field. All right? So if you got that number of kernels, if you got 10 kernels per square foot, and that over there, I'm going to use wheat because that's a number I remember vividly in my brain. Okay, 21 kernels per square foot in the field on every square foot in that particular field will give me a bushel per acre loss. Okay, so it's easy to reference to. Other things to look for is sometimes the weather is not nice to you. So the weather can affect your crop. Insect can affect it as well. Disease, and again, we talked about that one, the timing of harvest. So I just threw a picture in there showing this is a head of wheat, okay, compared to that one. This one is a heck of a lot harder to thrash than this one. So then you may end up with unthrashed heads in the grain tank and you fight yourself trying to get them out. Sometimes you win, sometimes you don't, okay? So you may not be able to adjust the combine to thrash this one out properly. But that's not the combine's fault. This was a disease in the crop. Another one that sometimes we forget about a lot is header loss. Okay, so if it can't make it from the header to the combine, there's no sense going any further. You have to adjust from the front of the combine towards the back. And I've always tried to brainwash myself that if I am adjusting your combine for too much loss behind the combine, you won't see me going out to the back of the combine. I'll go back to the back of the combine to see how much I have on the ground, but when I start adjusting my combine, I am going to start at the cutter bar or the corn head in this situation, and I'm going to analyze it to try to find out how much am I losing right here, because then I deduct that off of what I got behind the combine. And 9 times out of 10, if you start adjusting your combine from the front versus the rear, you're going to find your problem a lot faster. Okay, so always try to brainwash yourself. If I got loss behind the combine, it could be the header that's causing my loss. So I might as well start adjusting there. All right, header settings. Another one that's overlooked quite often is the reel. Now, comment down here, consistent and even crop feeding are the key elements to successful harvesting. So we got an expression we use at CaseIH that's garbage in, garbage out. Okay, so anytime that you have a bad sample in the grain tank, it could very well be coming from the way you're feeding it. So again, start adjusting from the front. Could be the reel pitch. These things are adjustable. Not too many people out there adjust their reel timing because it's not adjustable from the cab. You got to get out, you got to get some tools. And sorry, but some of us don't like that ladder climbing up and down because it's too much effort. So if the switch's not in the cab, it doesn't get done. So get off the seat, get down, and adjust the features that you have on the header first, and then try the buttons in the cab. It'll be much more efficient. You have got to feed that feeder house properly in order for any combine, doesn't matter which color they're painted, for that combine to perform properly. Headers is a big factor. For example, pickup heads. Pickup head's pretty simple. You lay a swat down, you run out there, and you try to run at 5 miles an hour and pick it up. But there is adjustments on a pickup head. Okay, so On here, I mean, guess what's wrong with this picture? I don't have to guess very much. I just look at it. The crop is coming up, it's going above the auger. That is not proper feeding. Okay, so you're going to have to get in there and do some adjustments. So this could be the belts are turning too fast. It could be the auger's turning too fast. There's two speeds on the auger. Okay, so you can get in there, change the sprocket over on the left-hand side to slow it down or speed it up. The height of the auger is adjustable. And then also the finger timing is another one that's real, I'm going to say critical, because I want to stress on it, because nobody adjusts the timing of the fingers. It's just supposed to be done from the factory. Okay, so at the factory, we do set them to where they are fully retracted at this position right here. This is the back of the header here. So this position right here is fully retracted. Not here, not here, down here. Okay, so you're looking at about 4 o'clock position here if you're looking from the left-hand side of the header. If I'm looking from the right-hand side, then it's going to be about the 8 o'clock position. That's your starting point. That's where we think they feed the best. Now, why don't we weld it there? Okay, we could weld it solid and then you never have to worry about it again. Well, the reason they're not welded, some other companies, there's no adjustments there. But on ours, everyone that's got an auger, whether it's a draper header, an auger header, or a pickup head, there is adjustment, because you might hit some conditions in the field that will be to your advantage to change the timing slightly to feed it better between the auger and the feeder chain. And that's why we make it adjustable. Sometimes though, what happens is if you happen to hit some rocks, it'll hit on the finger and it might slip the timing. So it's important before you start the season, start at the ideal spot, which is that position right there. Okay, so here's the adjustments. It's real easy to do. You got 4 bolts. You just loosen them up, put a wrench on the end over here, and rotate this coupler. You see the spline right here? And that will change the timing. Now the auger height, I talk about auger height as well. They do come from the factory in the lock position. So this block assembly right here is in the bottom position. So undo the 2 bolts, move the block up, and that'll give you 1.5 inches of float of that auger, which in canola, it's nice to have when you got those big heavy swaths. All right, moving on further into the combine. The next thing is the faceplate adjustments. This position from here over to the auger, in some conditions, are critical. Okay, so you need to have the auger as close to that feeder chain as possible. And that's being done by moving the faceplate. It's being done by moving the front drum position up or down. It's done by feeder chain adjustments as well. If the feeder chain's worn out and it's too close, or you took a link out of the feeder chain and now it's too far from the auger, it's going to impede the feeding. So you need to be conscious of those things. All right, adjusting the faceplate if you do not have, like for example, on the 250 series, we do offer the optional faceplate that can be adjusted from the cab. That's really nice. But if you don't have it, then you still have the ability to adjust it, but you have to do it by using wrenches. As you can see on here, this happens to be a 240 series combine. Okay, so you have 4 bolts up here and 3 bolts on the bottom. It pivots right here in the middle. So what you're trying to do is, if I got a pickup head, for example, you want this as far forward as possible, and it pivots in the middle, so therefore the bottom goes closer to the feeder chain, and then you get a better infeed off your dripper belts to your feeder chain. If I have a draper header, for example, all the way down, forward, tilted all the way forward, you're not going to be able to adjust the angle of your guard angle properly to be able to get the right angle. So you're going to have to take the feeder faceplate and move it further back. So what we look at basically coming from the factory, they are set in the mid position because we have no idea what header you're going to put on. Okay, so I get my combine. I know I'm going to start with a straight cut header. So I'm in the mid position. You're probably okay. But then as soon as I go to the pickup head, the best position is to loosen all the bolts and let it slide all the way to the end of the slot here. And then you'll be in the proper position for your pickup heads. If you do have a corn head you need the snouts a little further up. So you're going to loosen the bolts and you're going to rock it back to this position over here. And that'll give you the right angle for your snout on your corn head. Drum position. Drum position, there is a bolt on the side of the feeder, one on each side. And we'll get a close-up of that here in a minute. So that's how you move the drum up and down. While we're on this slide over here, you'll notice the mechanism for the adjustments to the feeder chain. This happens to be an 8010 photo, 8120. Okay, so there is no spring adjustments on here. It was fixed at that time. But we do sell a kit through parts that you can actually put a spring-loaded system on here, just like the new combines. Okay, so there's internal linkage and that needs to be changed, but it is retrofittable. Position of the front drum. If you look in your operator's manual, by the way, the operator's manual, that's that book that's in that box that's underneath the seat that some of you guys have never seen before. So if you go in there, you're going to see that in the operator's manual, find a page, and we'll give you the settings, okay? Corn position and other large grain, edible beans, all the way to the up position. That's the position they come from the factory. Mid position, small grain, edible beans, depending on the requirements, okay? So it's up to the operator to decide where it needs to go. I know in small grain, it is a lot more effective because in small grain, you need traction on that crop. So if the drum can come all the way down to that position, then it will drag the material up into the feeder house a lot easier. And sometimes if it's all the way up, it can't quite grab it. You've got to force feed it. And that's not good when you're force feeding. Lower position, basically for grass seed, okay, because the swath is usually not as heavy coming into the combine. So you drop it down to the bottom position. And I might as well tell you now, if you put it in the lower position, when you're running empty at the end of the field, you may hear the feeder chain tapping on the floor. That's not unusual, okay? If you don't like it, raise it up, just know, raise it up to the mid position, but just know that you're not at the ideal position, okay? Usually when there's crop in there, you don't hear any noise. It's only when there's no crops in. All right, front drum. There is a little window just below the bolt. Okay, it's just a little hole drilled into the side of the combine. And if that window is totally open to where I can see inside the feeder house, that means the drum is in the up position. If the window is partially blocked off, that means you're in mid. And if it's totally blocked off, you're all the way down with the front drum. And all you got to do is just loosen that nut over here, take a 1/2-inch wrench, put it on the end of the bolt because the end of the bolt's got a flat spot on it, and you can rotate it with the wrench. And then relock your bolt back in place. Okay, moving on to feeder chain adjustments. You'll see on here the spring. There's a gauge located on the bottom, and the gauge basically needs to be flush with the inside of the washer on this side over here. As long as it's flush with the inside of the washer, that's the right position. There's a spacer inside this spring, which is cut the same length as the gauge. Okay, so when you tighten this bolt down, it's going to get to the spacer, and then after the spacer's bottomed out, the gauge will automatically flush with the inside of the washer. If I keep torquing down on this bolt, I'm not going to collapse this spring any further because there's a spacer inside. It's just going to pull the bolt right through the spacer and over tighten your chain. So I always recommend when you're tightening the chain, torque on here until you feel that it's turning a lot harder, and then turn it back a turn and a half on the bolt, and you're going to be doing pretty darn good. You'll be right in the ballpark of where you need to be. Now the connector links on the chain. There's a proper way and a wrong way to put it on. So if you happen to shorten your chain, make sure that you put the nut side of the connector link away from this ring that you see right here. There's a ring welded onto here, and put the nut on the opposite side. Wherever the ring is welded, you're going to put the nut away so that it doesn't rub onto that ring that's welded onto the drum. Now, when you're working with used combines, it's going to get to the point eventually, the feeder chain is going to be wore out, so you're going to have to go in there and take some links out. And usually, when it gets to where it gets worn, the slats now become too close to this front plate right here. So you need to move the feeder slats away. So you take a connector link out, take a half link out, and that will increase this distance over here. And I always said there's no magic number to how far away I can be, but I can tell you right now that if you go more than about 1.5 inches to 1.75 inches from here to there, that's the shield that's up front here. If you go too far back, the feeder chain cannot reach the material to pull it into the combine. So if you get to that point to where it's too far, this distance is too far back, sorry, but you're going to have to buy a new chain. Your chain is worn out. So. All right, that's part of the feeder. Now let's move on into the heart of the combine. This is basically the heart of the axial flow combine is what we refer to. Feeder chain brings the material up at somewhere about 5 miles an hour. And then once it hits this area right here, if you're operating in wheat, the speed of the material needs to increase from about 5 miles an hour to about 60 miles an hour before it hits the RAS bars and your concave on the mid-range and the modules on the flagship combine. So that's kind of critical in a way that this area, if it ends up getting too much wear in it, because there's vanes inside there that wear, there's impellers that wear, so it is a wearing point. So you just got to keep on it every year, check it out, see if the wear is excessive. If it is excessive, you need to change the vanes, you need to change the lugs on the wear strips on the front of the gradual pitch impeller. Now, the other thing that goes with this is, you see on here that it also creates a vacuum, a sucking action of about 400 cubic feet of air from the front of the feeder chain. That air comes through from the header all the way into the feeder house, into this area, and then that air that's actually brought in gets distributed around the rotor and around the rotor cage, and that air also helps to push the grain outside of the rotor cage, and it helps with separation. Two things that it does. One, it helps with separation in the threshing area, and the second thing it does, which is most important, is you will see very little dust in front of your combine because it sucks all that dust inside the combine. And that all comes from this area right here. All right, threshing principle once you get inside here. And this is basically any combine, I don't care what color they're painted. Once you get inside the threshing area, every rotary combine has the same particular things that needs to happen inside there. 90% or 100% of the thrashing and 90% of the separation needs to happen in what we refer to as the threshing area. On a flagship combines, number 1 modules, number 2 modules, number 3 modules, number 4 modules. Number 1 and 2 is threshing area. Number 3 and 4 is separating area. Okay? So 100% of thrashing happens here and 90% of separation. This part back here basically does 10% of the separation. So that's why sometimes we're not big on putting blank off plates onto the thrashing area, because if you put blank off plates, that number automatically goes down. So if it goes down to 80% instead of 90%, that means this guy over here has got to do 20% of the separation. It is not designed to do that. Okay, so then you might end up losing past the rotor onto the ground. So again, be conscious that if I'm going to use blank off plates in the threshing area, that I'm encouraging rotor loss. So that's the part you got to watch. Multiple passes inside. And these multiple passes are controlled by the cage vanes. If I've got them on the 240 series and prior combines, all the way to 1977, there's 3 positions: slow, medium, and fast. When we went to the 250 series, we enlarged the window. Okay, so we have, if you got manual adjust, you've got very slow, slow, medium, and fast. But on all 240 series and prior, all the way to 1977, it's slow, medium, fast. Now in the mid position, you get 5 passes. In the slow position, you get 7 passes. And in the fast position, you get 3 passes. Okay? So depending on the crop that you're in, you adjust the vane to get the best thrashing and the best separation. This is showing simulating the rotor cage cover. That's the cage itself. That's what the vanes is bolted to. So this is all in the mid position. But if I need a little bit more thrashing, I'm going to take the vanes in the threshing area and stand them up a little further. And that'll slow the crop down so I get more passes on the concave. And then the other one stays in the mid. If I have too much rotor loss, then I can adjust the ones in the rear portion and slow them down to keep the stuff in the combine a little more. But just remember, the more you keep the stuff inside the combine, the more it breaks it up, then it puts more debris onto the cleaning system. More material other than grain on there. If I'm into an easy thrashing crop, I can put them in a fast position, get them out of there as quick as possible. I'm trying to bale straw, for example, behind the combine. Might not be a bad idea to put them in a fast position. They won't damage the straw quite as much. So if I'm in canola, maybe I want them in a fast position, because canola, if it's ideal thrashing condition, it breaks up pretty good, and then you overload the cleaning system with material other than grain. All right, here's a close-up of what they look like inside the combine. You can see the ones in the separating area right here. And there is some also in the threshing area all the way to the front. Now you can see the position here. Right now it's in the mid position. You slide them forward, you put them in this position right here, that'll be fast. You move them to this slot right here, that'll be slow position. So 3 position. All right, looking at the window. The window usually is a good visual. So you look at the window, you can see the sample in the grain tank. That's why we put a big window in there, so we want you to be able to just take a quick look at the window, see how clean it is, and then adjust your combine accordingly. Now, this happens to be wheat, and you see some white caps here in between the grain. And I always like to talk about this in clinics because there's some operators that if they don't see 100% grain on here, they panic. Okay, so there's no need to panic. Relax, because the combine is designed to have the dirtiest spot of the grain tank right against the window. So my measuring gauge is if I see white caps on here and I see grain in between the white caps, I'm jumping into my red pickup truck and I'm leaving the farm. Okay, because the sample is good. You need to go and look inside the grain tank to see how good it is, or better yet, go and look in the grain cart or in the semi, and then you're going to see that your sample all of a sudden improves a whole bunch. Okay, so don't be too concerned about getting 100% of the white caps out, because if you do that, you're probably going to end up with cracks, which cracks is worse than a few white caps. Okay, so be cautious when you're looking at the window. It's not the end of the world. All right, let's use a scenario that we have way too many. Okay, we do have tools that you can put in there to help yourself, because there are certain crops that you get into that white cap becomes a big issue and you have to beat them out of there. So as far as modules, we sell in modules what we call a hard thrash modules. The bars are actually tighter together than a small grain concave or modules. Okay, so but if you buy a kit, there's a big plate that comes on the bottom that covers the whole complete modules. So I'm going to say, wow, Louis just talked to me a little while ago and says if I put blank off plates on the concave, I reduce the separating area. That is correct. This plate for white caps, I do not recommend to put this plate on there. Okay, so put the module in, but forget the plate because it takes way too much horsepower and you're going to end up with way too many cracks. And also, with working in the field and playing around, adjusting this and trial and error, I find that I get the most out of my hard thresh kit if I put this modules in the front on the left-hand side. So that would be my first modules. I would put the hard thresh on the left-hand side of the combine. That's always sitting in the seat, by the way. Okay, left is left, right is right. Number one position, I put my hard thresh module. On the opposite side, right-hand side, I would put my in the kit also comes a plate that goes right above here and covers the hole in the rotor cage. Because right here behind this shaft over here, there is holes just like these ones or these ones. So you put a plate on there and you cover those holes on the left-hand side and the right-hand side. Okay? And that will keep those white caps inside the rotor housing and they get a second chance of being caught on the opposite side when they come back down. So that'll help to re-thrash the white caps. A lot of times, 90% of the time, all you need is the plates on. You don't even need to use the hard thresh module. Okay, so you can buy through parts separately, just the rotor cage plates, or you can buy the whole complete kit, which includes rotor cage plates and the modules. So it's your choice. I recommend put the plates only, and 99 times out of 10, it's good enough. All right, moving on to the separating area. Separating area on a flagship combine is a self-leveling cleaning system. Front end over here, you have your grain pan. Then you have your pre-sieve. Top sieve, bottom sieve. If you have a mid-range combine, you're going to end up with augers on here instead of a flat grain pan. That's okay. This purpose over here is to move the grain from here over to the cleaning system. Take it away from underneath the rotor cage and move it towards the back of the combine. On the bigger combines, we elected to put the grain pan because you need to start the separating process right off the bat. So basically the grain pan is oscillating up and backwards, and it takes the kernels, the clean kernels, it helps to move them onto the metal portion, and it moves the material other than grain above the grain. So then as soon as the grain comes to dribble off onto the pre-sieve, most of the clean grain is already on the bottom and the chaff is on top. So it helps to separate that stuff a lot easier. Now, sieve calibration. Well, if you do sieve calibration, there is in the monitor, in the Pro 700, there is a procedure for adjusting the sieve calibration. And we're going to have a section on adjusting sieve calibration. But for now, things I want to point out for you when you first look at your combine is to make sure that, especially on the pre-sieve is the adjuster is right here. Pre-sieve is up front. That's this part right here. Okay, here's the pre-sieve. Linkage goes all the way to the back here. So, I like to go and calibrate this thing, and once you've done it one time, then you pretty well know where it is. Okay, so because when they come from the factory, this thing is slotted over here, and I could be in this position over here, and the sieve is completely closed. Okay, so we do offer through the part system, there's a little gauge assembly that you can actually use as a measuring tool. I usually use a Allen wrench or a piece of key stock, anything that you've got that's got a good measurement. So what I normally do is I just set the gauge on here to where I have 1/8 of an inch on the pre-sieve, and then I adjust the quadrant and the linkage back here so that this notch over here comes right here. So I lock, the handle gets locked in the first notch. So I know now that the sieve will be adjusted at 1/8 of an inch. There's no crops that we go into that you need to fully close the pre-sieve that I'm aware of, okay? All the crops that we do that I've been exposed to, small grain, canola, grass seed, always 1/8 of an inch, okay? And then after that, my rule of thumb is, then you don't have to adjust the quadrant any more than whatever the size of the kernel is. So if I go to peas, for example, I'm going to take the pea and I'm going to use the pea as my gauge. Instead of using my fancy little gauge, I'll use the pea and I will move the quadrant so that the pea can slide in. The pea can slide in there, she's good, right? Soybean would be the same thing. I use the soybean. I don't fight myself. I use whatever the crop that I'm harvesting. I take the size of it and I just try to put it in there. If it fits, life is good. The only place where the rule doesn't apply is when you get into canola and grass seed, because I like to keep it within that 3 millimeter to 1/8 of an inch. So, all right, this section over here, what we're going to look at is a little simulator that we use in order to try and explain to customers what actually happens inside the combine. If you can see the bar graphs located up at the top end, and there's one for rotor loss, there's one for sieve loss, one for returns, one's for grain tank sample, and then the most important one is the one for engine load. As you can see on here, it's running at 90% engine load, and you can see the bar graph up top. It's all gone to that one line. Everything is green. That means that the combine is absolutely working flawlessly right now. So, which is something that quite often happens to customers in the field. You're operating, your combine's doing a really nice job, and then all of a sudden you see the clouds coming, and then you decide that, oh, I need to drive faster. So all of a sudden you push on the lever a little more, and as soon as you push on the lever, then you increase your ground speed, and you'll see on here, the minute that I increase my ground speed, you'll notice that up at the top end, if I look at my bar graph, it went from 90% engine load to 120% engine load. And you'll notice the rest of the bar graphs, the sample went dirtier, the rotor loss increased, the sieve loss increased, the cracks and broken increased, everything went downhill. Okay, so the reason why that happens is because in order to go from 90% engine load to 120% engine load, the engine actually grew in horsepower to go from 90 to 120. So you got lots of power. So you see the clouds coming, lots of power. So I can drive this fast. But in order to go from 90% engine load to 120%, the engine normally at rated speed is 2100 RPM at 100% of engine load. Once I push it to 120% of engine load, the engine RPM needs to come down in order to grow horsepower. So as soon as it gets down to about 1900 RPM, now you're at 120% engine load, and there's another thing that's happening at the same time. Rotor speed, I can go and increase it again, not a problem. I can increase my fan speed, I can adjust my sieve to try to compensate for it and clean my sample in the tank. But the one factor that you have no control over is the speed of the oscillating of the cleaning system. When it went from 2100 RPM down to 1900, the speed of the cleaning system is not running as fast. And that's what degrades the quality of grain tank and rotor loss and sieve loss. Okay, so can I run at 120% engine load to go through that one spot in the field? Absolutely. Okay, that's what it's there for. But in your own mind, you should be concentrating on the fact that maybe I'm losing a little bit more when I'm going through this spot, okay, which is totally normal, but you need to get there in order to push that crop through the combine, okay? So, but to run there at 110 and 115% engine load all day long, you might as well be prepared to have more loss behind the combine and maybe a little harder to clean the sample. So, on most of the time, I tell customers, run it at 90% engine load and you're totally comfortable. You can go to 100, but just remember, as soon as I creep up over the 100, cleaning system's not running as fast and it starts to degrade a little bit. So it may not be excessive loss, but like I said before, the more money, the more grain you put in the grain tank, the more money you put in the bank. So just remember that. So that's how a combine actually operates in the field. Over here, the one thing is clear to be able to point this out. When you're checking your combines, if you find that for some reason the sample, I can't clean it, I got too much loss, whatever it is, one of the easy things to look at is stick your head in the back end of the combine and have a look and make sure that your left sieve, this sieve right here, because they're in two, one here on the left, one here on the right. So measure the gap on this sieve and make sure that it is the same distance as this one over here. Because if rocks got in there or mice, dead mice, whatever, sometimes the linkage will slip a little bit and your left sieve will be more open than the right hand sieve. And if it gets like that, you are done. You will never fix the throwing over problem or the dirty sample in the grain tank. Because what happens is a little 10mm bolt located right here and it's slotted. So what can happen if there's some debris caught inside, sometimes it'll slip. And when it slips, it gets the two sieves out of adjustment. So you just need 10mm, loosen the bolt over here, there's another one back on the other linkage, just like this. And then take the handle, adjust both sieves so that they are equal, and retighten your 10mm bolts, and you're back in business. All right, now moving on to the next portion of it. Kill stall. Kill stall is being used when you have exhausted everything. You've tried every adjustment on the combine and you can't figure out what is going on. Why can't I stop this throwing over? Or why cannot clean the sample in the grain tank? The kill stall is kind of like a road map. Okay, so if you're totally lost and you've done everything, you do a kill stall. I always make a joke about this all the time because customers will tell me, Louis, I've tried every adjustments in the book. And I always go back to them and I says, why are you phoning me then? Because if you've tried everything, I don't have any more than what you got. Okay, there's no magic. All the adjustments are all in the operator's manual. So you missed something somewhere. Okay, so here comes the kill stall. By the way, the steps to do a kill stall is also in the operator's manual. All right, so find the section and follow the step by step, just like you see on here. Okay, lock the brake pedals together. Go and harvest at your normal operating speed. And then you put one hand on the hydro handle, the other hand on the throttle, and it's a simultaneous motion. Okay, so hand on the throttle, hand on the hydro handle, you pull the throttle back, you push the hydro handle all the way forward, squeeze on the brakes until the engine dies. Now you don't have to do this in 1 second. Okay, like I said, it's a gradual motion and then you'll get a nice kill stall slowly, life is good. And then everything will fall dead in its track, right where it needs to be, and then gives you an opportunity to go and analyze. Okay, now once you've done that, restart the engine, let it cool down a little bit, and then after that, shut it off. Okay, shut it off. That is the main important part. Just remember, you're going to be crawling inside that combine. If you're crawling inside the combine, you do not want the engine running. And it's probably not a bad idea to have the key in your pocket as well, so that nobody else can go and accidentally start it when you're inside. Okay, so safety first, and then after that, you go analyze. All right, so this was basically operating in, I've done it in 2 places, one in Arizona, one in Oklahoma. And when we did the kill stall, we go in there and we start analyzing. And if the whole system is operating properly, my sample is clean, I have no loss, life is really good, and I do a kill stall, what you're gonna see is, you're gonna see a pile of stuffed material onto the grain pan. This is the pre-sieve over here, so it's all covered up. This is the top sieve right here. If the top sieve is completely open, about 15 inches somewhere in there, and then the rest of it is covered up all the way to the back end of the combine, I can almost bet you dollars to donuts that you do not have any throwing over and you have a clean sample in the grain tank. It's almost guaranteed, okay? It's when it doesn't look like this that it's not good, okay? So now let's go back and we're going to do another kill stall after we readjust the combine and go through the same motion. We did another kill stall, we looked at it. All of a sudden you look inside here and you can see that, whoa, my 15 inches that I had over here, which was totally open before, now it's open way too much. So now you have to scratch your head and say, whoa, what just happened here? What could be the possible causes over here? Well, I've been operating combines for 40 years plus, and the one thing that I have learned in those 40 years is the fact that anytime that the sample is not clean enough in the grain tank, everybody that sits on that driver's seat will go to fan speed right off the bat. Fan speed is always the magic thing that fixes every ailment that we had got in a combine. It's not true, okay? So I get the comments all the time, you know, Louis, how come you only give me 1100 RPM on the fan? I need 4000 RPM. I could give you 10,000 RPM, you'd never fix it, okay? So this could be, it's too clean on here. So it could be a possibility of too high a fan speed. It could be the possibility of a upper sieve open too much, bottom sieve open too much, because it's allowing all the air to go to the top and it's over cleaning it. But in the meantime, it's throwing grain out the back end and it's giving you a dirty sample, okay? So in this situation over here, we had 15, 20 guys who were all analyzing, so we said, okay, which one is it? Which adjustment we do first? Well, from past experience, I know that most operator always run fan speed way too high. So I said, why don't we pick on fan speed? So we took the fan speed, we lowered the RPMs down. Because the reason why I picked fan speed, because I wanted to get more material on the cleaning system. That was my idea behind it. I don't have enough right now. So I'm going to use my fan speed. I'm going to lower it down and see what happens. So we lowered the fan speed down by 50 RPM. We went, did another kill stall, and this is what we found. Okay, so you can see on here that this trough over here is full all the way to the front. And these ones are open on the sides over here. So that was lowering the fan RPM. Now, if I increase my fan RPM, what am I going to get? There you go. Well, obviously that's not the right adjustment. So, now if I open up the top sieve wider, is this going to fall through there? Yeah, probably a pretty good chance. But don't forget, the picture down below on the bottom sieve looks just like this. So if I allowed this material to fall on the bottom sieve, what do you think this bottom sieve looks like right now? It's going to be worse. Once it goes through the bottom sieve, where does it go? Up in the grain tank. So that's why you see a whole bunch of chaff and debris in the grain tank. So in other words, any adjustments that I do with the cleaning system right here, top sieve, bottom sieve, fan speed, will never fix this issue. This has nothing to do with the cleaning system whatsoever. Okay? So now, where is it? Remember when I said when we started, always start adjusting from the header and move back? Now this is where you're starting. If you're bunching up on the header and it goes inside the feeder house and it's a more aggressive thrashing at one spot than another spot, you're going to dump too much grain onto the grain pan right in this area. Right now, what's holding this chaff down is there's way too much grain here for over here. So I need to take the grain off that grain pan and move it over here or over there somewhere to where I can equalize the amount of grain all the way across that precip. Once I get that accomplished, don't matter where I get the cleaning system set at. Okay? Cleaning systems are very forgiving. And if you run out of fan speed, that brings you back to possibly it is a thrashing problem. Maybe I should fix the thrashing problem first, and then I'll have enough fan speed. Okay? So over here, we all agreed that, no, we're not going to clean this with the cleaning system, so let's do something else. So what we did is we reduced the rotor RPM, and we went and did another kill stall. Reducing the rotor RPM moved the pile from here to here. But it's still not fixed yet. It's getting a little more open at the front, but this one's wide open all the way to the back end of the combine. So you're still going to end up with throwing over too much. So we knew that now lowering the rotor speed, that it moved the pile over to the right-hand side of the combine. So one guy said, geez, Louis, jack the rotor speed all the way up, see what happens. So we cranked the rotor speed all the way up, went, did another kill stall, and guess what? Now it shoves everything over to this side, and there's hardly anything on this side. So just moving the rotor speed up and down will move where the grain is falling onto this grain pan. Okay, you slow it down, it's going to move the pile over to the right. You speed it up, it moves it over to the left. Now we have to scratch our head a little bit and say, why does it do that? Well, the reason why it does that, on the flagship combine, the pinch point is bottom dead center right here. Okay, so if the pinch point is there, from the modules to the RAS bar, and if I had a flagship or mid-range combine from the concave to the RAS bar, is this wide, I can only allow so much stuff to go in between. So as I'm coming from the right-hand side, I'm coming down, I can't make it past the pinch point, I'm going to dump here. So if I slow the rotor speed down, I can't drive it through the pinch point, so it falls here. As soon as I speed up the rotor, I can drive more stuff past the pinch point over to this side. And then it increases the load on the other side. So rotor speed will affect what happens on that grain pan. Now, you've got to ask yourself the question next. What happens if I make that pinch point wider? I leave the rotor speed at the same spot, but I open up the pinch point. So now it's going to be easier to drive material past the pinch point to this side. And if I close it tighter, then it's going to force the stuff to fall over here. So by moving the concaves or modules up, tighter, it's going to dump to the right-hand side. Opening it up, it's going to dump more to the left-hand side. So now, you have to figure it out. It's all the operator. It's got nothing to do with Louis or anything like that. Okay? You're the one that has to decide which adjustment am I going to take. Okay? Sometimes I drive a little fast going down the road. I like speed. I like speed because speed is directly related to the speed of my ground speed. So if I speed up my rotor and I can fix the problems, that means that I might be able to just drive a little faster in the field and get the same thing accomplished. So for me, I always pick rotor speed. If that doesn't work, pick the adjustments of the modules or concave. Okay? Now, when you adjust, remember, it's not 200 RPM. Increments increase. All right? And after you do adjustment, don't panic when you look in the grain tank and you haven't cleaned the sample yet. We had a dirty sample before. I haven't cleaned it yet. Make sure that you drive far enough in the field. You got to remember, the crop has got to come from all the way up here, front of the combine, all the way to the back end of the combine. That takes X number of seconds to happen. So your changes, when you do changes, is not going to be instantly. Just let the combine fill itself and then see if you improved it. And if you did, good. If you didn't, try another adjustment. A lot of times what I do is I just use my sieve loss indicator. If I got a cleaning system problem, dirty sample in the grain tank, I will use 9 times out of 10, the sieves will be indicating that you have loss behind the combine. So you can watch it, and if you see it increasing, you've gone the wrong way. If you see it decreasing, it's helping, then you're going to see it come back up. At that point, quit playing rotor speed, play with your concaves or module position. And keep adjusting one at a time, okay? Do not just do 2 or 3 because you're smarter than everybody else. One adjustments at a time, that's the key with combine. And then you keep tweaking until finally This thing carries on, and guess what? You end up back to where you need it to be. Your sample is cleaned up in the grain tank. Your loss is cleaned up at the back end of the combine. So that's why you use a kill stall. So it's a good roadmap to tell you immediately what's going on. So the more grain that you can save, back to our old saying, more grain in the tank equals more money in the bank. Make sure that you have a safe 2020 harvest. All right? So good luck out there. Thanks for watching.
Hi there. We're going to talk to you about some of the options, some of the adjustments available on the 250 series combine feeder house. We'll start up at the front with the tilting faceplate. So we mentioned in another video, the reason we tilt the faceplate is to match the header type to the combine. It is not for adjusting cutter bar angle. All of the different heads typically have a cylinder located on the head for adjusting that cutter bar angle. Tilting faceplate is to match the faceplate to the head of the combine. With that adjustment, there are 8 big bolts on the mechanical adjustment style faceplate. So as you can see, we have 5 bolts up top, we have 3 down below, with the pivot point located in the center. So with a pickup head, for example, when we loosen all the bolts, we want to tip the top all the way forward. That brings the bottom in, that brings the auger in that pickup head closer to the front drum on the combine. Draper head, set in the middle, like you see this one is set here. They all come from the factory, set in the middle position. If you're swapping out to a corn head, you're going to want to tilt the top of that faceplate all the way back. That brings the front, or brings the bottom out further away from the front drum. Front drum height adjustments, so located right here. We have 3 adjustments, and we can tell the position of the front drum based on the little hole or the little window located just below the bolt. If we can see directly through the hole, that means that the drum is in the full up position. If the hole is half covered, that means we're in the mid position. And if the hole is completely covered on the inside, that means it's in the lower position. If we need to make adjustments, I find you loosen the bolt, and the easiest way to do it is to put a pry bar on the front drum and lift up and turn your eccentric whichever direction you need to go, up or down. Tighten the bolt and away you go. Feeder chain adjustment. So we've got a feeder chain adjustment or a tensioner located on each side, one on the right, one on the left. Spring-loaded tensioner. We give you an indicator gauge on how tight we want that spring. You bring the spring down so that it's just up against the back side of the washer. If you try to over-tighten this chain, you'll bottom out the spacer located in the middle of the spring, and it'll draw the draw bolt through the center of the spacer, again, over-tightening the chain. Tighten it down so the washer is just located on the back side of the indicator, and that's all you need. The spring will take care of the rest. All right, so we're over on the left-hand side of the feeder house, and we're going to talk about a few different things on the 250 series combine. One of the new features is the gearbox. So a lot of changes inside the gearbox. We mentioned a spline coupler, which we'll show you in a few seconds. The other thing is we got rid of the slip clutch in that top sprocket. So again, located inside of the feeder gearbox, so a fiber disc style clutch. Another thing I want to point out is we keep our operators in mind when we're designing our combines. We have the Rocktrap handle located on the side that the ladder is located. A lot of the competitive combines, you have to walk around to the other side in order to dump the Rocktrap. We want to keep your operators comfortable, so we put it on the left side. Swing the handle open, dump the Rocktrap, close it again. Pretty simple operation that way. All right, talking about feeder house gearboxes, we have a couple of the old style on the stand here, and I just wanted to point out the internal components we've been talking about. So the new bolt-on couplers that I had mentioned for the new style look like this and this. So this end here bolts on the gearbox shaft, so it would bolt onto the shaft on that side. This one would bolt into the sprocket, and then they're also a crown spline. So a crown spline means that there's a bit of a curve on that spline. It's not a perfectly straight spline. And what that allows is for some gearbox misalignment as it's bolted to the combine, and we won't get spline wear. In the past, if the gearbox was misaligned, we saw wear on these splines located right here. If we are pulling these gearboxes off of a previous model combine, good idea to make sure that you're laser aligning those gearboxes when you reinstall. The other thing to take note is those new parts won't fit on an old style gearbox. So unfortunately, you have to have a 2019 or newer combine to have these new parts. All right, so let's talk about some of the different display settings available on the 250 series combine. You can see we have a new run screen available. In the top left corner, you can see we have our crop type, rotor RPM, cage vane position, concave position, fan RPM, pre-sieve setting, top sieve, and bottom sieve, all located on one page. Engine load, bushels per hour, bushels per acre, and along the bottom you'll see the funnels have changed, and we have some different options there. We'll have sieve loss, rotor loss, tailings. The other thing I want to go through, let's go through some of the automation settings. So we hit our back button in the bottom left corner. We touch our automation tab, which is new. And if we scroll over to the beginning, our basic settings. So we pick our crop type out of the drop-down menu. All of our different crop types. Keep in mind that the supported crop types for automation are wheat, barley, canola, corn, and soybeans. So I'm going to go ahead and pick wheat. Strategy, performance, max throughput or fixed throughput. For 95% of what we do in Western Canada, you're going to pick performance. You set your max ground speed. So my recommendation for that is to set it for no more than 1 mile per hour faster than what you would typically travel in the field. So if you can do 4 miles an hour in the field, we'll set that for 5.0 miles per hour. Target max engine load, I like to set it for 100. Remember, the sweet spot on our combine is somewhere between 80 and 100% engine load. So if we set it for 100, the combine will only go to that 100% engine load range. The advanced settings. So we have a couple different things in here. Initial settings. So we can automate on this combine based on your own settings, which would be current setup, or if you want to use the ACS settings pre-programmed in the display, we use automatic. Adjust frequency. So essentially the sensitivity as to how we want it to adjust. Low, medium, or high. I typically recommend setting it for medium to start. Threshing condition. This one is fairly important. So we have 3 different options: easy, medium, and hard. Now, you may be inclined in a tough situation to automatically set it for hard threshing. Our recommendation is to set it for easy threshing no matter what the field or the crop type is like. Easy threshing gives you the full range of parameters, so it gives the combine full range or free range to use the entire range of automation settings. And so it's definitely recommended. Start with easy threshing. If you find that you're lost, we have a reset automation button. We can typically hit the button. It'll ask you yes or no. Do you want to reset to factory defaults? You hit yes and away you go. The other one I want to point out is status. So if we hit the status button, we can check on the status of all of our different sensors for automation. So I have the grain cam unplugged on this camera, and you can see it's giving us a stop warning. That grain cam is unplugged, so it sees an issue, sees a problem. So it just gives you a quick way to check all the status of all the different sensors. Ranges. So late last fall, we gave you the ability to set ranges on some different things. So again, another place to set our crop type and our threshing condition. The one that we'll probably use the most in Western Canada is our precip range. So if we click on it, we can set our minimum and our maximum. Good idea with the small grains that we harvest in Western Canada, especially if we get into tough conditions, that we might want to set our minimum at 2 and our maximum to about 6 millimeters. That way that precip isn't going to open any more than 6 millimeters. Keeps our wind speed in check and gives us more adjustability in our automation system. The next thing I want to talk to you about is some of the adjustments with feed rate in the drive tab. So with the new hydrostat we have in this combine, there's some adjustments that we can make in the display. So we're going to go into the toolbox. We hit our back button, toolbox, and along the bottom we look for the drive tab. All right, so there we see it. Drive tab brings us to this display right here. Auto econ turned on, so set to yes. What that's going to do is as you're traveling down the road, the engine high idle speed will actually come down significantly in RPM. One for fuel consumption and less cab noise. Feed rate sensitivity, typically set to medium or high. If you have varied conditions, you might want to set it to high. Or if there's a little bit tougher conditions, you might want to set that one to high. But medium is a great place to start. If we scroll to the bottom, you're going to see two settings, high range max and low range max. So basically, when the combine is set in low range, we can set the max ground speed. So when we're hooking up to headers, you'll find that if we set it all the way to 10.4, that your hydro might be a little bit jerky. So what I like to do is set it for a reasonable range. So if we bring it down and we set it for about, say, 6 or 7 miles an hour, as long as you're set for a comfortable speed that you'll be traveling in low range in the field while you're harvesting. So set for 7 miles an hour gives you more adjustability on the hydro handle when you're in that low range. High range, I like to leave it all the way to the max because typically when you're in high range you want to travel at the highest speed possible. Next thing I want to take you to is some calibrations. So we hit our back button, we're going to go to our calibrations menu, and along the bottom you'll see yield and moisture. So these ones are two fairly important settings for an operator. The biggest thing I want to point out there is you're going to have to do your moisture calibration before you do your yield. So we touch moisture, and we recommend that you use the wizard. So when we hit the wizard, it'll bring you to this page. You run the wizard, and at this point all you have to do is follow the on-screen instructions. So it will give you step-by-step instructions on how you perform the moisture calibration. When we toggle over to yield, same thing. You can see it looks like a similar page. We use the wizard, run the wizard, and it will bring you through a step-by-step instructional on how you do the calibration. Back to our run screen, we hit run, and we're back to our main page. Hi there. Let's talk about some different modules and some different settings in the module area on our 250 series combine. So the first thing I want to touch base on is concave pinch point. So located up in this area right here, when we're talking about concave pinch point, basically it's the tightest position of the concaves to the rotor. On flagship combine, so it's been true since the 8010 combine, we want that pinch point set dead center of the rotor. So basically where the two modules come down from the left and right side, we want that pinch point set so it's tightest at the dead center position on that concave frame. So we want that concave sitting tight in the middle of the combine. Very important. We don't want it sitting off to the left or right. You're going to find the best performance when it's set in the middle. The modules on a flagship combine are all interchangeable. So we have position 1, 2, 3, and 4 on the left side. So all of the left side modules are interchangeable with each other. We can put the small wires in the back. We can put the large wires up front. However you wanna set them up. Okay. Talking about hard thresh conditions a little bit. So we have the option that we can run a hard thresh module. You can see here we've got small wire modules in there, and we can change them out to put hard thresh modules in there. So if you're in really tough conditions, if you've got the wheat is baked into the head, 2 bolts up on top, that module will drop down, slide out, and you can change it to whatever module you want based on your crop conditions. Very common setup is how you see this one set up right here. We have 2 small wires in the front, 2 large wires in the back end of the combine. The other thing I'd like to talk to you guys about is our new adjustable vanes. So located up in this area right here on top of the rotor cage, I'm just going to crawl up there. If you look up here, you're going to see some linkage up there that you've never seen in the past. You're going to see your vane position indicator, and you'll see the actuator located up there. We have the ability to adjust those from in the cab if you have the electric adjust, and we'll point out a button located in the battery compartment in a minute. Alright, so let's talk about the precip button. So this is a new one. With automation becomes electric precip adjustment. So we have a button located down here for calibration purposes if you need to calibrate the actuator on that precip. So you can open and close from down here. You can also do it from in the cab. And then the third option is the automation adjusts when the automation system is running in the field. Okay, so on our cage vane linkage, you can see where my finger's pointed. We have an indicator indicating whether it's in the very slow, medium, or fast position. So as the cage vanes adjust, this linkage will move back and forth, and it will change the angle of those vanes. Rotor gearbox shifter, so 3-speed rotor gearbox located on this handle just under here. Chopper stationary knife located right here. So this pulls the knives in and out. Pull out, pull down for adjustment, or up to drop the knives out. Pretty straightforward that way. Okay, moving a little further back on the combine, we're going to talk about some of the battery box area. Pretty straightforward, gives you a nice big toolbox. Located inside the box though, we have an electric switch for the cage vanes. If you need to clean them out, you need to move them from externally on the combine, we have a switch located right here. Again, also adjustable from in the cab, and when automation is running, it's going to be adjusting those cage vanes as well. A little bit of a fuse panel located in here, and again, like I said, nice big toolbox. You have a couple of light switches, so your side panel lights and your Sieve area lights, battery disconnect, chopper speed adjustment. So we have a high and low speed. So with a mechanical shifting chopper like this one is, we squeeze the plates together and we can slide the coupler back and forth. Change the speed from high to low or low to high. Last thing I want to talk about, located up in here, we have our chopper belt tension. So 2 indicators, again, spring length to the end of the indicator. Doesn't need to be any tighter than that. We don't want to over tighten the belts because it will put deflection on the shaft in the chopper. The other important thing to mention is if you do have a new combine, those belts will stretch quite a bit in the first 20 minutes of operation. So after 20 minutes, you're going to want to get out, you'll tension these belts, and then again in another hour after that. Get out, check them, make sure they're still tight, and after that they should stay tight and you can service them via the recommended interval. So the last thing we're going to talk about on the left side of the combine over here is the importance of proper rear axle height setting. So a couple factors that we take into consideration: rear tire size, and how we measure it is by putting an angle gauge on the frame rail of the combine. So we don't want to see any more than 4 degrees, right? So basically we don't want the rear of the combine lifted any more than 4 degrees than the front of the combine, which is a fairly flat plane, to be honest with you. In our travels, we've gone out and we've seen, and we've had questions from customers that have lifted the rear axles on their combines all the way to the top, expecting that they're going to save more grain in the combine. That is not true. This combine was designed to run at 4 degrees. Don't set it any higher than that. All right, so on the back end of the combine, we're going to talk about a couple different adjustments back here. This combine has the electric deluxe residue package. So with that, we get 3 different actuators available. So 1 actuator on each paddle here, and then there's also one on the center, which sets our whale tail. The actuator in the center sets the gap between the tail and the top of the panel. This gap determines how much product we're putting in the center of the spread versus the outside of the spread. The larger the gap located right here, the more product we're going to put in the center. If we want to direct more of that product to the outside edges, we close that gap up. These two actuators located right here set the clearance between these fins and the impeller paddles. The tighter these fins run to the impeller paddles, the harder it's going to throw that product. Great for wind compensation, great for directing more or less product to one side or the other. If you have the mechanical version, these actuators are replaced by mechanical turnbuckles. So you'll have a threaded rod here, here, and also located in the center. The last thing I'll talk about in this area, if you're in really green, tough conditions, especially we see it in canola, what we'll find is you can get a little ball of material build up between the impeller paddle and this fin. And what happens is it'll stall the impeller motor. If that happens, typically you wind up plugging up the back end of the combine. So in those tough conditions, we have some bolts and some slotted holes located up here. We can loosen those bolts off and we can bring this whole assembly away from the impeller paddles and give you more clearance in there. And that'll help push those green balls of material through and prevent plugging. On the right hand side of the combine, we're going to talk about a couple different adjustments and maybe some tips and tricks to help you do a better job of your harvest. We're going to start with the tri-sweep tailings processor. So under this panel right here, we have our tri-sweep tailings processor, and that's basically going to take all the material out of that return system, process it, put it back on the cleaning chute. One thing to keep in mind is if you are in green, tough conditions, we can get some buildup on the inside of that processor. One helpful tip is on the inside, on the deflector, on the inside of the combine, we can actually remove it. And when we remove that deflector, it will help material from building up starting at that deflector and moving down through the tailings processor. It'll help keep the tailings processor from plugging up and keep you running smoothly. As we rotate back, we have our clean grain elevator chain adjustment, right? So we have an adjusting rod and a bracket on the elevator. Once the washer on the adjusting rod becomes close to the bracket on the elevator, it's time to start removing links from the elevator chain. To do that, we go in through the bottom boot down here and remove the half link if there's a half link available. If there's no more half links available, chances are that elevator chain has reached the end of its service life and it's time to replace it. All right. As far as the chain adjustment goes, we do go in through the bottom of the boot. We come down here, we adjust the chain, and we just want that chain to slide back and forth on the sprocket itself. We don't want it pulling down off the sprocket. If it'll pull down off the sprocket, that means it's too loose. So it should just slide back and forth a little bit. Moving forward, we have a clean grain camera. So 250 series combine with automation has a camera. Looks like this right here. Located on the moisture bypass unit on the inside of the elevator, held in with 2 pins. All right. On occasion, we're going to need to clean this camera. Your display will tell you when it's time to clean the camera. We pull the front pin out, that camera will rotate out of the way, and we can wipe it off with a soft cloth. Keep in mind, we don't want to scratch the lens. We just want to make sure we give it a wipe to clean the material off. Pretty straightforward that way. Next, we have the actual moisture sensing bypass unit. So you'll see this guy, again, on the inside of the clean grain elevator. There's a couple different components to it. We have the actual moisture sensing fin. We have an electric motor, a fuse, and a little auger to empty the unit. On occasion, especially in green conditions, we experience a lot of them in Western Canada, we're going to have to clean this unit. So the moisture sensing fin, for example, again, don't use a screwdriver or a scraper to clean it off. Make sure you're wiping it with a rag. If you find it won't come off with a rag, you might have to wet it just a little bit to soften it up and then clean it off. If we get buildup in the auger, we pull the 2 pins out. We pull the auger and the cap off. and that lets us get in there to clean out the auger and the tubing assembly. When we reassemble, you're going to have to feel for a couple different clicks. So we need to line up the spline on the auger itself. We get one click, we keep rotating till we get the second click and the cap is in place. Insert the pins back in and the unit's ready to go back together. If we do find we get the auger jammed up, there's a chance that you may have burnt the fuse. So if you follow the wire that goes into the motor, you have a little fuse holder there. If you're traveling down the field and your moisture is sitting at the same moisture all day long, never changes, there's a good chance that this fuse has burnt because we've gotten some buildup in the auger, and perhaps there's some material that has hardened in there and won't let that auger turn.
Welcome back to our session of optimizing your combine. In this session over here, basically what we're going to do is we're going to have a little better close-up of the components so that you can kind of identify exactly what can cause issue with your machine as you're operating in the field. So if we start at the front with the feeder, first thing that I always comment to customers is to make sure that they inspect the front end of their combines before they get out to the field and start harvesting. So in the morning, it's good practice is to activate the feeder reverser, to check your bars, these bars, onto your feeder chain to make sure that you don't end up with any bent bars. For example, I have a bent bar located right here. As you can see, it's got quite a bit of a bow in it. And what happens when they bow is the distance of the chain between here and here becomes narrower. So now, when the chain, this bar that's bowed, ends up at the top feeder shaft, the sprockets are actually welded onto the shaft. So they don't move. So what has to move is the chain itself, and it's trying to straighten this bar. So as you can tell, this is a cast piece. It gets pretty difficult to straighten it. So what happens is the chain itself, it will pull on the links sideways, trying to break the chain. And as the chain keeps going around the top sprocket, just imagine, you can do 44,000 turns over that sprocket pretty quick in a day, and you do that 44,000 times, and it's just going to pull that link completely off, and you now have a busted feeder chain. That's usually what happens. Okay, so the previous slat that we had, they were made out of metal. Okay, so metal bent a little bit easier. So if I look at the 230 series combines, the 20 series, the 8010, they were a metal slat which could bend quite easier than the casting that you have over here. So that's why we went to casting on the later 240 series and the 250 series combines. So again, we want to put the slat to be a lot more rigid than the previous one to eliminate chain breakage. That's the whole idea behind it. Now, these cast slats, I always get the question, can they break? Well, there's your proof right here, okay? Yes, they can break, but usually what will happen is stay attached to the chain itself, and you're going to hear a racket inside the feeder house, and hopefully you can hit the kill button before you go any further and do any other damage. So, now, on the chain itself, we went to a heavier chain in the 250. You heard Victor talking about it. The main difference between the chain is if you look at the inner link over here versus this one, you're going to see that this one is quite a bit thicker. And the pins are also a bigger pin. So this is a much stronger chain than what we had before. Okay, so this would be your 960H. This would be your CA 557 chain. That's what we used in the past. This is what we use on all 250 series combines. Now, this chain can fit on a 240 series combine as long as it has the cast slats on. The cast slats cannot fit onto a previous combine because of a ring that is welded right here. And the ring is interfering with the cast piece that you have on the back. So in order to put that slat on an older combine becomes a little bit more difficult. And some people say you can turn around and you can cut that ring off. We do not recommend to do that, okay? Because if you cut the ring off to accommodate the slat, probably the drum is going to break in that position. So if you decide that you want to put this whole complete feeder chain off a 250 onto a previous combine, there's a kit. There's a new front drum. There's going to be new chain tightener on the side here. New chain tightener as well, okay? So that's to go from a newer 240 series combines to an older 240 series, 230 series, 20 series combines, okay? All right, so that's the feeder chain portion of it. Now, a couple of other things that I always point out to guys as well to make sure you don't run into issues during the season is if you pull out this coupler and you look at it, these should all be flush. If you look at them and they're recessed, that means there is debris inside these couplers. So you need to take them apart and clean them. Sometimes they're probably an O-ring maybe that's flipped over and they'll end up probably leaking. Leaking is not a, well, I shouldn't say it's not a big issue. Leakage, you'll see it. It's when the coupler is not opening properly that you don't see, and what it'll do is it'll cause some overheating in the hydraulic system. That's the part that you don't want, okay? So have a quick inspection on these and also the plate that's actually on the header itself as well. And if you don't see them flush, just like you see here, you got a problem. So you might as well fix it before you go to the field. All right, so if we move a little further back, I talked about strippers on the top feeder shaft. That is located in here. You take that shield off of here, and then it gives you access to the top feeder shaft. And then you're going to see these strippers on there. And when I mentioned a little while ago in the PowerPoint that this adjustment we're looking for is the sprocket fits right inside here. So the sprocket needs to be no more than 1 millimeter from this portion right here. If it's more than 1 millimeter, you're going to end up with wrapping on the top feeder shaft. And sometimes what happens is you'll adjust these bolts here, it's slotted, and you'll adjust them closer, and these will hit the shaft itself before I can get to my 1 millimeter. If that happens, you can buzz some of this portion off over here and get your clearance a little tighter. So this is what will eliminate, or I should say probably reduce, the opportunity of material going around with the sprocket and causing the chain to jump out of time. Okay, further up into the cone area, I mentioned in the PowerPoint that we had vanes. These are some of the vanes. This is not the vanes that's actually in the transition cone area. These are actually the vane that comes off of the rotor cage, but we can use these as a sample. Okay, so what is too much wear? Okay, so what I look for is if I put these two side by side, this is the new one, this is the old one. If you've got over 1/8 of an inch material gone, 1/8 of an inch to 1/4 inch gone off of that vane, she's ready for the garbage can. Okay, so take a new one, measure it, reach inside through the stone trap area and measure the ones you got on there, 1/8 of an inch to 1/4 of an inch, you're done for the season. Okay, so get some new ones put in there, because you remember that's the heart of the combine and everything needs to be smooth operating in there. No delays. It needs to get that crop accelerated to the right speed, and the more wear you have, the less speed you're going to get, and it's going to affect your thrashing inside the combine. So then you're going to end up with unthreshed heads and all that kind of stuff. Okay, so that's what you got to look for. Any of the vanes, 1/8 to 1/4 inch, you need to replace them with new vanes. Okay, so we'll move on to the next section. Okay, in this particular area of the combine, one of the things I want to talk about is the electrical system, or charging system, if you want to call it. A couple things to kind of be warned about a little bit is batteries have a tendency of discharging, whatever. Battery goes dead, you need to replace it, whatever. There is a decal on the side over here, pay attention to the decal. Okay, so a couple of nice things to know about this is, first of all, it'll tell you if you're just going to boost the combine, you can go and use the booster post that you have on the sides over here. But if you're going to charge the battery for an extended period of time, it tells you on the decal to remove the cover off the top, because there's fumes that's actually coming off the batteries as it's charging, and there's potential for accidents to happen. So remove the cover, preferably charge the batteries from the top, and preferably charge the battery independent of each other. There's two 12-volt batteries in there. The electrical system is a 12-volt electrical system, but the starting circuit is a 24 volts system. So what happens is when you start cranking, it'll combine the two 12 volts into 24 volts. And that gets done by this module that's located right here underneath this shield. That module looks just like the one that I got in my hand right here. So inside here, it'll convert from 12 volts to 24 volts for cranking. Once it's done cranking and the engine starts, it reconverts back to a 12-volt system. So batteries are dead in the morning. You show up, you want to boost it. So you go and you hook up your booster cable. Pickup truck comes up, you hook them up, and you accidentally hook them up backwards or whatever. Things can happen. There is fuse inside here. This is one of the fuse right there. I got my finger on it. It's a metal strip. And if you burn one of those metal strips off, what will happen is it will not crank. It'll just make a ratcheting noise, and just like I call it the rattlesnake noise, and you'll never get it started because it will not allow you to crank. So as soon as you hear the rattlesnake, just go after this guy, look at these. If you burnt out that fuse, you need to put another one in, okay? Now, that's okay for the 250 series, that's okay for the 240 series, but some of the 230 series, we had a different system on there. It had what we refer to as a trickle charger. This box assembly is not in this location. So if you don't have this box, that means you've got the previous system or the interim system, and it had a trickle charger located underneath the clean grain vertical auger, okay, up in that area. There's some modules in there that was doing the charging. That system does not charge as fast as this particular system. So you need to run quite a bit. So what I'm trying to get at is if you're in the yard, you start the combine probably 10 times without going to the field on the same day. There's a possibility that the second battery is going to be discharged too much, and then you're not going to be able to get it started because the voltage is going to be below 11.4 volts. It'll crank, but it will not start, okay? So I strongly recommend before you start the season, take the batteries out of the combine, charge the batteries, fully charge both batteries, put them back in the combine. And then you start the season with a fully charged system, and life is good from there on, okay? So that's tidbits on the charging and electrical system, and that might alleviate a lot of issues in the field. So make sure you start with new batteries, fresh batteries, fully charged batteries, okay? All right, on to the next section. Okay, now let's move on to the threshing system. A couple things again to try to understand how the threshing system actually operates. First of all, there's a couple of different versions of threshing mechanism that we use inside here. So on all axle flow combines, you can get a small tube rotor and a standard tube rotor. So what we refer by a standard tube rotor is the tube itself is bigger. It's 30-inch in diameter from here to the opposing rasp bar down below on the standard rotor. On a small tube rotor, it is 30 inches from the top of the rasp bar to the opposing rasp bar. But the trick is the tube is smaller. How much smaller? Here's an indication. Okay, so this is the rasp bars off a standard rotor. That's the same ones as what you're seeing right there. Here's the rasp bar off a small tube rotor. You can see the difference between the two of them. Okay, they're still on they bolt onto the rotor tube, and you can see the difference in height between the two of them. So the tube is smaller by that much, but you still end up with a 30-inch rotor. Small tube rotor is, most of the time, standard rotor is the one that's being used in the combine. The small tube rotor was designed for the areas that are harder, heavier crops, harder to thrash. For example, rice is one of them. Or the northern part of Alberta, northern part of Saskatchewan, Manitoba, those places where they have heavy crops, doesn't dry up very much. The small tube rotors will actually increase your capacity by approximately 20% more versus a standard rotor. Now, 20% sounds great, but there's a price to pay. Okay, so now I want to make it clear to everyone so that you understand that if I elect to go to a small tube rotor, I'm going to have to be prepared to put up with a little bit more rotor loss, and I got to be prepared to do a little bit more fine tuning. So those are usually the questions that I ask. If you don't mind fine tuning your machine, I'm okay with selling you a small tube rotor. If you're okay with a little bit more loss behind the combine, I'm okay selling you a small tube rotor. If you don't answer yes to both those questions, you're going with a standard tube rotor, okay? So it is a little bit finicky to adjust. Rotor RPM usually got to run about 100 RPM faster than a standard rotor, but it will give you that extra capacity, so you get your money's worth, all right? So that's the only two things that you got to watch for. Next thing that I want to talk about is the modules. If you look on the bottom over here, you're going to see I have a small wire modules, I have a large wire modules, I have a round bar, I have a slotted one. And the large wire one, if I want to make it a large skip wires, I simply just pull the wires out. Now I'm missing a couple over here because I also got a cover which is totally flat, looks just like this except it's a smooth plate. Those are the ones that you'd use if you went into sunflower seed, for example. Okay, so we call them modules because when I was talking prior, the first two modules is the thrashing area. The last two modules is the separating area. Okay, so if I expect that concave over there to do a proper job in wheat, for example, I'm going to put a small wire in position 1, small wire in position 2, large wire number 3, and large wire number 4. So these, the reason we call them modules is because if I call these concaves and I took the concave from here and I moved it to back here, what do I call it now? Because this separating area, most combines would call it grates. So that's why in the flagship combine, there's no concaves. They are modules, and you can interchange between the front one to the rear one, take the rear one, move it to the front. So on a mid-range combine, I have 3 concaves on the front, and I have 3 grates in the back. They're not interchangeable from the front to the back, so that's why they're called concaves and grates. Flagships, modules all the way through. I can interchange. I cannot go left and right. They don't fit because the right ones are half an inch shorter than the left-hand side, or vice versa. I can't remember which one it is. One is about half an inch longer. So it gives you the ability, by having modules, to be able to go and tweak your combine a little bit better once you identify where the grain needs to come out, where I need to be more aggressive with thrashing. So it's a little bit more flexible than a standard concave grate combines. All right, now let's talk a little bit about what these bars on here can do, or what they're there for. And this is, since this is kind of a live thing, reality sets in. So you're going to look at my modules, you're going to say, whoa, Louis, couldn't you find a better one than this? Okay, you can see where it's all bent. Okay, that's done by design. Okay, so obviously this guy that had this module in, he had some non-compressible objects in the field, so he put them in and he bent his bars, and he also knocked the wires completely out of his module. This is reality. That's what happens in the field. When you're inspecting your combine, this is what you're looking for. Okay, so if you see any damage in here, if it gets to the point to where it's bent too much, you're going to have to replace them and put new ones in. Now, what's the concept behind these things? If I turn around and I'm inside the combine looking at this, just try to imagine yourself as being crop coming through here. These bars that are in here, we always ask the question, what are they there for? And a lot of people will answer, oh, they're there for thrashing. Well, in reality, they're not there for thrashing. Okay, they are interrupters is what they do. Now, the bars on the rasp bars, the rasps you have on here, again, I always ask the question, what is this for? And people says, well, thrashing. So if these are worn out, then I get less thrashing. Not necessarily. We do sell some in parts that are smooth, just like this, on the top. Okay, those are the ones they use for popcorn. So, what do these things do and what do these things do inside the combine? Okay, I mentioned interruption. The crop, as it's coming in, it gets interrupted. These bars are on here to keep the crop moving through the combine. Now, the flow of crop through the combine is at an angle like this. If I looked at conventional combines when we first started, the concave inside the combine was in this direction, and the cylinder was in this direction. You had a one pass, and then the reason why most companies went away from conventional combines to rotaries is because the kernels were at the straw and kernels are coming this way, and they were hitting each bar bang on. In rotary combines, we took the cylinder, we put it lengthways in the combine, and we changed the position of these modules or concave in the mid-range. So now the crop is actually flowing at this angle as the rotor is turning. It comes across, the kernels are hitting over here and they're bouncing back inside. It's not a direct hit onto the bar. And that's what makes thrashing a lot more gentler. So that's why the industry is kind of changing over to rotary combines to try to get a better sample in the grain tank, because cracked grain does not bring you money. You've got to get the kernel in the grain tank as plump as you can. That's what you get paid on. Okay, so that's a little bit of an explanation on why we do things sometimes. It helps to understand, because I always get the question, why did engineering do it this way? Why this and why that? That explains a little bit of what's happening inside there. Okay, small wires, basically is used for small grains, grass seed, wheat, barley. If you get a kernel that is too big that don't fit between the wires, then I got to go to the bigger module. This one over here, large wires. So I got more spacing, so kernels can fall through there a lot easier. Sometimes peas, corn, soybeans, you name it, right there. Next one is the round bar. Round bar is for gentle thrashing crops. If I don't want any cracks, for example, I'm harvesting peas. I don't want any cracks. So the round bars will still thrash because it's an easy thrashing crop. It just pops open and the kernels can come out of there. Soybeans, high moisture corn, okay, that type of material. Round bars work excellent in there. Slotted, you know, if you get into edible beans, then you might want to go to slotted because there's none of these bars in there that's actually hurting the kernels. It's just a flat piece of metal with holes punched in it. So a lot more gentle on the seeds. Okay, now moving on a little further back. Now we discussed those. There's also another one that I don't have here, which is called the hard thrash module. The hard thrash module has small wires just like this one, but the bars are a little tighter together. So I get more interruption out of it. And then the wire spacing is a little tighter. So then that way it holds the white caps inside here a little bit better, so you get a second chance at grabbing them and thrashing them out. Also with the hard thrash kit comes these cover plates. There's two of them. Okay, this one over here, the solid one, will fit not in the first section. It'll fit in the second section in the rotor cage. Okay, not on the bottom of the modules, on the rotor cage itself. So these tabs are here, you can bolt them in place. This is the one that fits on the right-hand side. This is the one that's going to fit on the left-hand side, on the opposite side. The slots that you have over here are used so that once I install the plate and I want to move the vanes, I don't have to take the plate off. The bolts of the vanes will fit through here. Now this works fine on 240 series combines and prior, right down to the 8010s. And for the Western Canadian guys, I strongly recommend that you don't fight yourself, just get them, put them on. Once you put them on, they stay there forever. Okay, now, on the 250 series with the adjustable vanes, the ones with the turnbuckle and also the automation ones that are electric, this plate no longer fits on the left-hand side because the linkage is interfering with the plate. But in all the demonstration we've done and fields that we've gone into during harvest, the linkage that's over top of the rotor cage is actually plug in a whole bunch of the holes already. So not necessarily needed on a 250 series combines. If you get into real extreme conditions to where you cannot thrash it out, then you can still use the right-hand side one. It'll still bolt on there, okay, because it's open on that side. But what we found with automation on the 250 series combines is with the vanes moving to the very slow position, medium, and fast, there's enough vane movement on there that we found that it does a way better job of thrashing when you get into hard thrash wheat. Okay, so you can really clean up the sample, really nice. That's usually the comments we get is, man, I've never seen a sample like this in wheat. So that's what the vanes moving can do. Now, we mentioned prior in that the vane position is what you use for speeding up or slowing the crop flow through the combine. But the 250 series, there's more movement to the vanes, so you get a better thrashing out of it. So, okay, that pretty much, oh, one more thing, I almost forgot. These bars, okay, they're bolted on here. Any place on the rotor that you see two rasp bar that are in line, okay, so like these two right here. These are two in line here, so that bolts right on there. I can't bolt it here. There's no place it doesn't fit because there's no other bars that actually line up. So the thing is these are bars that you install to slow the crop down inside the combine. Okay, corn, for example, is a good one because the kernels like to hide in the leaves and the husk, and then they won't get out. So you'll stick these in there to put them in there. However, if I order my combines and I get the combine coming in and the bars are already installed, like this one, and I'm out doing wheat, canola, peas, lentils, those bars are not needed in there, okay? So they do take a little bit more horsepower. So if they're in there, you can remove the bar and install rasp bars with a spike, just like this guy right here. My regular rasp bar that I had on here does not have this spike located right here. So this is what we call a spike bar. Okay, so you would take and install spike bars where that bar came off. Another bar is this guy right here. It's called a kicker bar. These fit at the back end of the rotor, right here. Okay, so if you end up, I'm going to use, for example, if I go into hemp. Hemp is a crop that it's like a rope. Once you put it in there, it likes to rope, and it will keep tightening up just like a rope does, and you have a hard time getting it out of the rotor. That's where these guys come in to move the material through the combine a lot quicker. Okay? Now, if you get into serious conditions where you end up with excessive rotor loss that is uncontrollable, I wouldn't be bashful about bolting some of these in there. Okay, I've done it in the past. See where the straight bar is? If the straight bar's not there, this bar will go take the first hole and it'll take the bar that's right above it. And then you can put them into, not necessarily at the back end of the rotor, but in the number 3 position. Make sure you put them 180 degrees apart from the one that's at the back. And that will help to reduce the amount of rotor loss that's happening. Again, if you look in the operator's manual, there's places where they show you where to put these bars. So it kind of helps you to understand a little bit more. So, all right, so that's basically it on the thrashing portion of the 240 series, all the flagship combines. Okay, thank you. All right, this section here, we're going to be basically talking about the cleaning system and trying to understand a little bit what the theory is behind the operation of the cleaning system. So first of all is all flagship combines have what we refer to as a self-leveling cleaning system. And self-leveling cleaning system means that the whole portion that you have over here will actually oscillate from left to right underneath the combine. And I'll just walk up to the front here and just hit the switch, and you should be able to see it move back and forth. Okay, it'll oscillate over to the left and then oscillate over to the right, or vice versa. Okay, so it's good for approximately 12% slope, somewhere in that area. So when you're working in the field, constantly this thing is moving from side to side depending on which way the cab is actually, the cab is the one that determines if the combine is level or not. And then it sends a signal to an electric actuator and make sure that the cleaning system is level with the body of the combine, so that you can make sure that this grain pan stays flat all the time. So again, we talked about grain pan a little while ago. Grain pan itself, what it's there for is to stratify the grain from the chaff. Okay, the shaking motion, forward and back, tosses the material up. The grain is heavier than the chaff. It'll automatically fall down faster. Clean grain will be on the bottom, chaff will be on top. Then it moves towards the back, hits what we call the precip. The precip allows 10% of the kernels to fall through there onto another similar grain pan as this, underneath the precip. That grain pan brings those clean kernels over and dumps them down onto the front of the bottom sieve, so they get cleaned one more time. I talked a little bit about the adjustments of the precip. The adjuster is located at the back, so I go and adjust the adjuster over there in order to set the position that I want this. And again, my rule of thumb is just that you never want to close it below 1/8 of an inch or 3 millimeter, and then from there on, you never want to open it any bigger than the size of your kernel. So use your kernel as your measuring device. Moving on a little further back, I have the top sieve, and underneath I have my bottom sieve. Now, the angle of the sieves becomes a little critical. So again, if I use an angle finder and I put it onto the frame of the combine, this is the lower frame, I put it on there, and then if I am more than 4 degrees up at the back end of the combine, I need to lower the rear axle. And again, a lot of people says, well, why is that? Well, because if you raise it too high, how the system actually operates, if you look at my arm over here, if I take the whole body of the combine and I raise the back end up, and I'm going to exaggerate with my arm, okay, so now it's quite a bit steeper. The movement of the shaking system, if I'm level, the movement goes rearwards and up, like so. Okay, so the reason it's doing this is so they can toss the material up in the air and at the same time move it towards the rear of the combine. So if I toss it up, that's where the air can actually get underneath. The chaff is lighter than the wheat or any crop that you're doing, so it'll take the debris and it'll blow it out of the combine and allow the kernels to fall back down, go through the sieve and go through the bottom. Now, if I raise the back end of the combine like this, the shaking motion is the same. It goes up like this. But as I'm moving it towards the back of the combine, I'm catching it again, and then it wants to roll forward. Debris, it cannot jump up as high, so the air doesn't have as much chance to get underneath, lift the chaff, and let the kernels fall through. And then you end up with dirty sample in the grain tank, and you end up with loss. So just be conscious not to get too crazy with the back end and jack it up, because most people think if they jack it up, they're going to save more grain. That's not the way it works. Okay? You cannot change the geometry of the profile of the combine. You need to stay within that parameter. Now, difference in sieves. There's different sieves available for the combine, and in the operator's manual there's a page in there that tells you how to measure the sieve and how to identify which sieve that you have. Okay, so basically a way to measure it is it's measured from the wire that's holding the louver to the next wire. So there's 1 1/8 or 1 5/8. 1 1/8 is mostly used for small grain. 1 5/8 is used for other grain. Okay, so this sieve that you have here on top happens to be the small grain slat. The one that I have over here, it's 1 1/8 from here to the end, to the other wire. That happens to be a closed slat. The one that you have over here, if it was in 1/8 from there to the end, 1 5/8, sorry, 1 5/8 from here to the next wire, that happens to be a corn slat. 1 5/8 is a corn slat. 1 1/8 is small grain. So I can get a closed slat, 1 5/8 as well. The only difference between this one here and the one that you have over here is the finger, the opening is wider. If it's closed in this area, just like this one right there, that's what we refer to as a closed slat. Okay? So that's basically the difference between the sieves. Okay, next thing I wanted to talk about is the back end of the top sieve. If we look down in here, we'll notice that this area is open back here. There's a piece missing here. This wire assembly actually goes right in there, and there's wire fingers over here covering this area. This one's been removed so that we could see where the rubber flap would fit. All new combines come equipped like this. They have a rubber flap bolted at the back end of the top sieve. So this rubber flap would fall down into here and basically close the area that the wind can come up through here to go through the wire. Because if the flap is underneath here, there's no wind can come through here. It has to come through the sieve. We added this at the factory. It used to be an option at one time. Okay, but there's some areas where people thought that we should have more air coming through the sieves instead of coming out through the fingers at the back. So we added this rubber flap at the factory. Most of you guys, with an 8010, 8120, 9120, 230 series, the first 240 series, do not have that rubber. It was only added at Curtin. It was added the later part of the 240 series and then the 250 series. Now, sometimes in small grain, it can cause you some issues because sometimes it's nice to have air coming through the wires to catch some of those on-thrash heads and let them fall through here and go down into the returns. When I have the rubber over there, there's no air coming through here. So whatever doesn't get through the louvers gets blown over top of it, and it can cause you some grain loss, especially in wheat. So pay attention to it. If you cannot control your sieve loss behind. It might be that the curtain is causing you the issue in certain conditions. 9 times out of 10, the curtain can stay in there and be okay. But I've ran into conditions where I physically had to take it off. That was the only way to control the loss behind the combine. So, okay, hopefully that kind of helps explain a little bit about the cleaning system.
So we're at the back end of the cleaning shoe. We're going to talk about sieve calibration. Now when we start a calibration, we're going to go into the display, we're going to go into the calibration menu, and we're going to pick sieve calibration, upper and lower, and follow the instructions on the screen. Those instructions will tell you to set your sieve opening to 1/4 inch, measure it, and then confirm it. So we go to the back end of the combine. We'd use our buttons located on the left frame rail to adjust the sieve. Don't use the buttons in the cap, all right? Physically be at the back of the combine using the buttons. We close our sieve down all the way, and then we start opening the sieve using the buttons until we get that 1/4 inch or 6 millimeter clearance. We slide our gauge into the finger, verify that it is set for 6 millimeters or 1/4 inch. We go back into the cab, we complete the calibration, and that's all there is to sieve calibrations. Very important, you start with the start of the season, do your sieve calibrations, make sure they're set accurately. The more accurate you are back here, the more accurate your display will read in the cab. Next thing I want to talk about with an automated combine while we're at the back, sieve pressure sensors. So this is a bracket taken off the side of the combine, and we have 2 sensors, 2 on each side. One that will sit just above the top sieve and one that sits between the top and bottom sieve. They're located in about that location right there. One important thing to mention with these is cleaning, all right? We don't want high pressure water sprayed inside the sensor. So if you're washing in the back end of your combine, take some duct tape and put it over top of the sensor on the frame rail. We don't want to get water down in there. You can take a soft bristle brush if there's some material covering it and just give it a little brush, right? Some of that green stuff will stick. These little brown pads are actually like a foam filter almost. The way the sensor operates, it's an air pressure sensor. So it's measuring the pressure of the air from the cleaning system against the sensor pad. So just something to keep in mind with sieve pressure sensors. On behalf of everyone at CaseIH, we want to thank you for taking the time, viewing our videos, watching our training, and I hope you enjoyed everything that we provided for you. We also want to thank you for your business. If it wasn't for you guys, we wouldn't be in business. We wouldn't do the jobs that we do. We enjoy working with you, and we thank you for that. Also, I want you to have a safe, happy, and productive harvest.